Now that we've drawn and completely labeled our critical region graph, hence the reason this is called the critical region approach, we can now go to step 5, which is to compute our test statistic and then make a conclusion on the null hypothesis. Again, we're doing a t-test, so this is the test statistic. So let's plug in all of the information. So we've got t equals x bar. The sample mean hours of the phone battery life was 23.2 minus the hypothesized mean, which was 24, which is part of the claim by the phone company, divided by the sample standard deviation was 0.9 over the square root of the sample size was 50. So don't forget, if you're going to plug this entire thing in your calculator at once, which I recommend so that you get an accurate representation of your test statistic t, you got to make sure you have parentheses around this numerator and parentheses around this denominator. And when you do plug this into your calculator, you get t is approximately equal to negative 6.29. This is our test statistic based off of our sample data. Now, once you've done that computation, you need to make your decision on whether you should reject H naught or fail to reject H naught. Again, I'm just going to say accept H naught. So you got to use this graph, and we got to see where this test statistic falls. Where does it fall on this number line here? Negative 6.29 would fall somewhere all the way over here, right? Because negative 2.010 is greater than negative 6.29. So it falls out in this tail. And recall, the shaded tails are what we call the rejection region. So that means because this is so far out here in the shaded area, we need to reject H naught. So let's actually simply write that down. We want to reject H naught. Now remember, the mathematics is built on either accepting or rejecting the null hypothesis. You now need to see how this applies to the claim. And that is our final step, step 6. To make your conclusion about the claim and interpret the results, we need to look back at step 1 and step 5. So step 5 we just completed, we saw that we should reject H naught. Now you need to look back at step 1, and this is why it's so important to label everything clearly in step 1. You got to see what your claim is. So in this particular case, the claim is the null hypothesis. So since we are supposed to reject the null hypothesis according to the test, and the claim is the null hypothesis, that means we are going to reject our claim. And the claim was that the battery life was 24 hours on average. So we are now going to officially interpret our results. And whenever you interpret the results, you should always restate the level of significance because this result could change if you had a different level of significance. So again, we did this at 5% level of significance. So at 5% level of significance, we reject the claim that the mean battery life is 24 hours. We've now officially completed our first problem on hypothesis testing on the mean using the critical region approach. Since we were developing the ideas in the 6 steps along the way, let's now look at a summary of all 6 steps together on one screen. Again, the problem we were given, a cell phone manufacturer says its average battery life is 24 hours. We randomly collect a sample of 50 of their phones and test their battery life. The average battery life of our sample is 23.2 hours with a standard deviation of 0.9 hours. At 5% level of significance, should we believe the company's claim? So we're trying to decide whether this claim that the average battery life is 24 hours is legitimate or not. So step 1, we defined our complementary hypotheses, and we noted that the null hypothesis was the claim in this case. In step 2, we noted that the level of significance was 5%, which was given to us in the problem. And in step 3, we decided we were doing a two-tailed t-test. In step 4, we drew our critical region. Again, we drew the t-distribution because we're doing a t-test. And since it's two-tailed, we've got 2 shaded regions, each tail, and we found these critical values in our t-distribution table. Then we went over in step 5 and computed our test statistic. Then we ultimately needed to see where this thing fell in the graph, and it falls way over here, out here, one of the rejection regions. So in step 5, we reject the null hypothesis. Finally, in step 6, we have to decide, does that mean we accept or reject the claim? So in this case, we found out that at 5% level of significance, we reject the company's claim that the average battery life of their phones is 24 hours. This is what your standard write-up should look like when doing the critical region approach for hypothesis testing on the mean. Let's now take a look at a whole new problem where we use the critical region approach.